Hello everyone, this is Shrwan Sir making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today's topic is area of triangles and quadrilateral from class 10 compulsory math. Dear students, in this video we are going to prove theorem 2. Here we go. Dear students, the statement of theorem 2 is the relation between the area of a triangle and area of a parallelogram standing on the same base and between the same parallel lines. The statement is area of a triangle is half of the area of a parallelogram standing on the same base and between the same parallel lines. Dear students, if a triangle and a parallelogram are standing on the same base and between the same parallels, then the area of triangle is always the half of the area of parallelogram. So let's prove this. Dear students, at first we have to draw proper diagram. In examination, you have to use ruler and pencil. Don't use ink pen. Dear students, we have to draw a triangle. So let us say ABC is a triangle which is on the base BC. Then we have to draw a parallelogram. Another figure we have to draw a parallelogram. So let us say BCDE is the parallelogram. And both are standing on the base BC and they are between the same parallels BC and AD. So if a triangle and a parallelogram are standing on the same base and between the same parallel lines, then the relation between area of triangle and area of parallelogram is half. That means area of triangle is half of the area of parallelogram. So let's write down given at first. Dear students, a parallelogram. Dear students, triangle ABC and a parallelogram BCDE and a palm, insert we can write a palm BCDE. A triangle ABC and a palm BCDE are on the same base, BC. The base is BC and between the same parallel lines BC and AD, and between the same parallels BC and AD, between the same parallels, or we can say parallel lines, between the same parallels BC and AD. Dear students, now according to this theorem, we have to prove the relation. According to this theorem, now we have to prove the relation between area of triangle ABC and the parallelogram BCD. We have to prove that area of triangle ABC is half of the area of parallelogram BCD, area of palm BCD. So dear students, now according to this theorem, we have to prove area of triangle ABC is half of the area of the parallelogram BCDE. Let's write down proofs. Dear students, at first we have to take. Dear students, now to prove this theorem, we have to take a construction. We have to take a construction. Draw MN Draw MN perpendicular to BC. So dear students, we take a point on the line AD. Wherever we want, we can take. So we take a point on AD and draw MN perpendicular to BC. That means we'll draw MN making 90 degree with the base BC. So this is the construction. Draw MN perpendicular to BC. Dear students, now let's write on the proofs. Dear students, now let's write on the proofs. Statement number 1. In the examination, we have to write down, we have to make a table, we have to write on serial number, we have to write on statements, again we have to write on serial number and regions. So we have to make a proper table. So this is in statement number 1, we are going to write the area of triangle ABC. We are going to find out the area of triangle ABC. Dear students, we know that the area of a triangle is half times base into height. Half times B into H. That means base into height. 1/2. The base of triangle ABC is BC. Base is BC. And height is MN, which we have taken the construction. MN is the height. Dear students, the reason for statement 1 is area of triangle is half base into height. Dear students, the reason for the statement 1 is area of triangle is half base into height. 1/2 times B times H. Next, we have to find out the area of palm BCD. Dear students, now we have to find out the area of parallelogram BCD. Area of palm BCD. Dear students, we know that the area of a parallelogram is base times height. B into H. Base times height. Base. The base of parallelogram BCD is BC. So we can write BC. And height is MN. According to our construction, the height is MN. The height will be the same because they are between the same parallel lines. Now the reason is, dear students, the reason for this statement 2 is area of palm is equal to base times height. Now dear students, now in this statement 3, if we combine statement 1 and 2, then we'll get the proof of the theorem. Area of triangle ABC. From this statement 1, we have area of triangle ABC equals 1/2 times BC times MN. Dear students, in the statement 2, BC times MN is the area of parallelogram BCD. So in the statement 1, we'll replace the value of BC times MN, which is equal to the area of palm BCD. So in the statement 1, dear students, in the statement 1, BC times MN, which is also equal to the area of palm BCD. Area of palm BCD. So dear students, by combining statement 1 and 2, we have got area of triangle ABC is equal to half times area of parallelogram BCD. The reason is from statement 1 and 2. The reason for statement 3 is from statement 1 and 2. So this is the proof of the theorem 2. So I hope that you have understood how to prove theorem 2, which is the relation between area of triangle and quadrilateral. Next time we'll visit with the new content. Till then, bye. Have a nice day.